So 1.2 kilogram ball drops vertically onto a floor hitting with a speed of 25 meters per second. It rebounds, and we want to know the impulse and the force. So once again, this is an interesting trick question because I can only, it seems, calculate the change in momentum. So for part A, let's actually calculate the change in momentum. And that'll be mv minus mu, and it rebounds, so let's be really careful. So we have 1.2 rebounding, meaning it goes backwards. I don't know why it says it rebounds with an initial speed of 10 meters per second. Oh, I know what they mean by that. It means that it rebounds. They should just say it rebounds with the speed of negative 10. And it hits the floor with a speed of 25. That was poor phrasing on their part. I know what they're trying to say. They just didn't say it very well. So we're going to get negative 12 minus, and 1.2 times 25, I believe, is going to be 30. Minus 30. So we've got a change in momentum of 42 newton seconds. So what does this have to do with part A? Let's be clear. The change in momentum equals the impulse. So this also equals the impulse when we calculate it. Now we can say for part B, negative 42 equals F times the contact time. So negative 42 equals F times 0.020. And that's going to give us a contact force of 2,100 newtons. Let me make sure I have that right. So 42 divided by 0.02. Wow, 2,100 newtons. Pretty impressive force. All right. A force of 6 newtons acts on a 3 kilogram object for 10 seconds. What is the object's change in momentum? Once again, we can calculate the impulse, which is the change in momentum. So that'll be 6 times 10. 6 times 10, which will be 60 newton seconds. And we want to know the new velocity. So we're going to say that F times T, F times T equals mv minus mu. That'll be 60 equals 3 times v minus 3 times 0. When we isolate, v will end up being 20 meters per second. All right, next. A constant force acts on a particular mass. We know the initial velocity. We want to know the final velocity, and we're told the direction of the force and the velocity are the same. So let's start with Ft equals mv minus mu. That's going to be the 300 times the 68 seconds is going to equal 600 times v minus 600 times the 10 meters per second. We're expecting, if it's in the same direction, the thing ought to go faster. Let's just do a little math. So 300 times 68 gives us 20,400. Right. So 20,400 equals 600 v minus 6,000. That will give us 26,400 equals 600 v. So our final v is going to be 44 meters per second. All right. So that's a review of the required homework problems. I will give some hints on the challenge problems when we get back from break, as we will have some warm-ups and we will be continuing our work on conservation of momentum when we get back.